8 o'clock in the Pacific and also 11 Eastern Time. Thank you all for joining us on our webinar this morning. We're going to focus on offshore facility process safety. We're going to provide overview and familiarization. And thank you for joining us. My name is Steve Maher. I'm with Risk Management Professionals. Those of you who aren't familiar with us, we're a process safety and risk management engineering consulting firm. We work with the petrochemical industries, both onshore and offshore, to support SEMS, RMP, SPCD, and also related programs. Our game, we're going to take some of our insights and our background and try to share a little bit of information on some commonly applied safety management systems. Also some practical tips. A lot of you are going to wonder, what is a safety management system? It's a national term that's commonly applied in the United States. A lot of people have heard of such things as process safety and also risk management programs. Again, thank you for joining us. A quick note on webinar mechanics. For the initial presentation portion of the webinar, we've got to keep the participants on mute, otherwise shuffling papers, the noises and everything else are going to basically get broadcast to everybody. And in some cases, we've had problems where it actually drowns out the speaker. If you do have any questions or comments, the chat box can be used to send a message to our producer, Nicole Otramba, and she'll go to interrupt the speaker or pose a question if there's something important that needs to be brought out at that time. There will be a question and answer period at the end. During that time, everybody will be unmuted. Questions can be asked either directly or anonymously, and we'll be happy to entertain questions like that. One of the covenants that we've got to have for this particular webinar is, given that the Deepwater Horizon accident, the Macondo well release, emergency response efforts, and incident investigation efforts are ongoing. Those things are really not subjects that we want to address as part of this webinar. We're going to be addressing specifically safety management systems and how it goes about implementing loss prevention programs. So our focus is on those techniques, and what we want to do is provide you with some familiarization categories, understanding SMS or safety management system concepts, reviewing applicable tool guidelines, things that have been available for some time from the American Petroleum Institute, safety environmental management programs, safety environmental management systems, safety studies, and analogous programs that are out there that have been very helpful to a lot of people for quite a bit of time. We're also going to be talking about practical approaches for implementing loss prevention programs, and we're also going to be providing a little update on some of the current regulatory environment and how it affects SMS. So what to do is introduce our next speaker, or actually our first speaker, Brawley. Ester Brawley is currently a senior engineer with Risk Management Professionals. Her career began in the maritime industry as a shipboard engineer on merchant ships. She received her Bachelor of Science in Mechanical Engineering at the California Maritime Academy and sailed as a marine engineer on commercial ships. She joined Risk Management Professionals over 6 years ago and has played a key role in over 120 facilities of all sizes with training, development, and management of safety management systems to address overlapping regulatory requirements and voluntary company programs. Her career crossed over to many industries, including but not limited to petrochemical, furniture manufacturing, agriculture, food processing, ammonia refrigeration, chemical plating, chemical etching, water treatment, wastewater treatment, and power generation. She trained an experienced HAZOP LOPA facilitator. In addition to providing this kind of support, she's provided existing processes for long-term clients and has participated in 8 major refinery and polysilicon monosilane expansion projects during the FEED process and also the engineering, procurement, and construction, or EPC phases. And Esther, welcome, and thank you. Back off on this one.
Okay, so we're just going to do a quick overview of the key topics. We've got personal hazards versus process hazards, kind of going over the very basic difference. How's that? I think I had on stamp. So we're going to cover the key topics, which are personal hazards versus process safety. What's the difference? A lot of people get them confused. We have obviously the evolution of the various guidance and regulations out there that people are drawing from now on like more of a voluntary basis. Example, state and industry programs are in use today. No sense in reinventing the wheel. There is stuff that we can draw from in industry that's being used and implemented. Obviously, we have the SEMS element review and implementation suggestions. Just trying to simplify it and get to the basics. And obviously, comparison of offshore SEMS regulations and guidelines, 2010 update for SEMS regulatory framework, and then basic business issues, and then questions and answers. Okay, one of the things about offshore applications is their unique hazards, obviously, for obvious reasons. You have frequently changing activities, very well conditions. Obviously, it's a compact environment, so you have much higher consequences and risks involved, and challenges from an emergency response perspective in the sense of evaluation and agency support. Get into categories. With personal safety, which is like lost time injuries, slips, trips, and falls, dealing with PPE, confined space entry, lockout, tag out, these things protect you from personal safety. You usually have different disciplines with different expertise in an organization that are focusing on personal safety and trying to bring those rate numbers down. Process safety is a whole different animal. It's a corporate culture issue. It involves people from disciplines, engineering, maintenance, operations, process safety experts, experts. You have management buy-in. It's a corporate cultural thing, and requires a lot of different disciplines. You can't just hire a process safety management coordinator and okay. You have to get all disciplines involved. One person, two people, never going to accomplish what needs to be accomplished. A little bit of overlap, but once again, just to kind of, the best analogy that we can come up with to kind of understand the differences is, and this is commonly done when you're analyzing a company and looking at their safety history. A lot of times the information that's analyzed is their lost time injury information. And that's, common used in industry is to say that's correlating the airline baggage handling injuries to the risk associated with airplane crashes for a specific company. It's an indicator, it's great to look at, but we're looking at two totally different animals. And so that is similar to the correlation of offshore facility slips, trips, and falls versus, risks that can major accidents. Once again, you have to have multiple disciplines. You're not going to just hire a safety coordinator and get it done and have them auditing it. It's a day-to-day living program. Okay, sorry. And obviously, once again, involvement of personnel from multiple facilities. What I found is the best programs, the companies use the cross-pollination. Might have a program on site. But time things become normalized, risks become normalized, procedures and record keeping become normalized. It just becomes so, mundane. It's hard for the people on site doing it on a day-to-day basis to recognize they've kind of fallen behind in certain areas. So it's really important to bring in advice to kind of look at the culture and help with the auditing and cross-pollination. Once again, serious accidents usually represent the tip of the iceberg. Personal safety indicators, lost time injury statistics, very helpful at gauging how the facility is doing in a personal safety arena. Safety is different, and all applications, all industries that I've worked in struggle with process safety indicators and recognizing them and understanding what they are. Near misses, really investigating near misses, that is definitely an area that a lot of people in industry struggle with, not just offshore but onshore too. I think it's because, incident investigation is kind of a volatile word, and, it's okay to investigate lots of things and see where you can improve your organization. I mean, that's the whole point. Basically, normally, a near miss or a process safety indicator happens frequently, constantly, over and over. Those can become normalized because of direct consequences or injuries happen. And you hear that so many times. We've been doing this like this for 20 years, you know. When I come in to help, when people hire me to come in and help them with their organization, that's always what you hear. We've been doing this for 20 years. You know, what are you doing showing up here and telling us you have to do things differently? So they don't recognize it as a risk because it's become lies. And this is a common kind of logical thing that happens. And it's usually summed up as just a maintenance work order, not a near miss or a process safety indicator. And near misses, but the real definition near misses, I mean, it's kind of vague, it's kind of all over the place. But basically, it hadn't been discovered, if you hadn't corrected it in time, it could have resulted in maybe a catastrophic event or an injury or release. These are some examples of common process safety indicators or near misses that you see over and over again in different industries, different onshore, offshore applications, and you talk to people trying to get a feel for how they're looking at things and what their organization's doing, and these common things that come up, and then you kind of have to call time out and say, well, wait a second here, let's look at this a little bit more detail, because once again, this has become normalized. Very often, oh yeah, we have to, during certain operations, or that vessel's always filling up, so we just put stuff there and just drains it off periodically throughout the day. Obviously, something like that is a deviation design intent. That's a process safety indicator that maybe needs to be looked at. You shouldn't have to rely on stationing an operator like a human control valve to drain the vessel. Oftentimes, oh no, what is that liquid? You know, the liquid's in the tank. It's not supposed to be in that tank. How did it get there? You know, there's some deck, valves or lineups that got overlooked. Maybe it was hidden behind a deck plate or something. Things maybe aren't readily available, or they don't have access to them. They're not up to date, so we can, check their lineup. Most times doesn't even result in an accident, an injury, totally non-event. Regulating via the bypass. A lot of people do that everywhere. They close out, they isolate off a control valve, and they're regulating pressure, temperature, level, flow, whatever, via the bypass. And the operators are just are doing that. And, it just becomes normalized. They don't realize, wait, that's a deviation from the design intent. The control valve was the design intent. That deviated from it, that's a process safety indicator. Relief valves are leaving a lot. Something that happens so many times, oh, that always happens when we shut down. Oh, that always happens when we stop. Oh, that always happens when we shut down that piece of equipment. Meant to be a pressure control valve, meant to be there for safety as a layer of protection. So that's, once again, deviation from design intent. Using an ESD, emergency shutdown device, as part of your shutdown, it should be there as a safety device, as a layer of protection. Increased corrosion rates. You'd be surprised. They just say, oh, inspection picked up increased corrosion rates. We got that to the next step. Say, why? What's causing it? Is our metallurgy adequate? What do we need to do about that? Is that normal? And of course, constant repeated fouling of equipment, constant repeated premature failure. You need to look at it further. Now I'm going to turn you over to Steve, and he's going to go into lessons learned from key facility incidents. Steve Maher is currently our principal engineer with Risk Management Professionals. He's been a safety consultant for over 30 years. He's, for the past 26 years of his career, focused on high-quality applications of process safety, risk management, and loss prevention technologies, such as SEMS, and RMP, for a broad spectrum of industries. Nuclear, you name it, Steve's there. Mr. Maher received his bachelor's in mechanical engineering degree from Duke University, master's in mechanical engineering from Carnegie Mellon. He's a certified safety professional. He holds a professional engineering certificate in mechanical engineering in the state of Pennsylvania, mechanical engineering in California, He's been actively involved in process safety since the 1980s when he performed a hazard analysis for several Alaska North Slope facilities. Steve was definitely one of the first ones performing HAZOP studies, and the lead engineer for a landmark 1989 evaluation of platform safety shutdown system reliability using fault tree analysis and quantitative risk assessment techniques. So I will turn you over to Steve.
Hey, thank you, Esther. The challenge I got here is make sure I don't spill my coffee this morning, too. I didn't talk about lessons learned or things that have happened in the past that have emphasized the importance of safety management systems. I really want to do that for two primary purposes. Consistent with the theme of our discussion this morning, I want to familiarize and identify some of the safety management systems that are out there, discuss their evolution, how that correlates to accidents that have occurred in the past. And a key thing I'd like everybody to get out of this presentation is there are tools and techniques out there, a variety of them that have been applied to several different industries that are very effective in loss prevention. So that's what I want to focus on. So our main theme today is for offshore process safety systems. I do want to just mention one critical event. There have been a number of accidents, obviously, that are associated with offshore facilities. One of the pivotal ones was Piper Alpha. The tragedy that occurred in 1988. Essentially, there was a work permit system not being used at the time, and somebody did remove a relief valve. It was blinded off. A pump was turned on. A lot of gas condensates were released, and there were 167 lives lost associated with that. As earlier events that we'll talk about in a few minutes, the pivotal event for the offshore industry, highlighting the importance of managing safety. So again, that's safety management systems and techniques to help you control the level of safety at your facility. PIPA, like many others, basically provide a lot of insights in terms of major incidents. Major incidents have caused significant loss of life. The implications of the loss of life and property are business interruption, lost confidence in contracts, increased duration. And look at the root causes of all these major events. A lot of them are from relatively simple precursors in initiating events, and the root causes are often the failure to maintain the design intent. The equipment was designed with a certain function in mind. Somehow operations were conducted or played out such that it went beyond the boundaries of those design conditions. In a lot of major events that have occurred in the past, including Piper Alpha, one of the most effective mechanisms for improvement was identified as not by addressing the specific actions or the specific causes of events, but by impacting the way business is done, looking at how business is done, finding ways to improve that, and basically this is overall encompassed by safety culture and also management systems concepts. Let's talk a little about evolution. I see the Piper Alpha event in the offshore industry as having some direct parallelisms to what occurred in the onshore facilities. I was actually had the privilege of serving on the technical steering committee for the Center for Chemical Process Safety in 1985-1986 timeframe. You will recall that that's in the aftermath of the Bhopal tragedy, and also a major event that occurred in Mexico City, both of which resulted in a lot of lives lost. At that point, the CCPS was formulated, industry grouped, and to look at what the occurrences were, what the main driving forces were for the accidents. And one of the first things that was done in 1987 was publish a technical guideline for the management of safety systems. This was an industry initiative to address a problem that was pretty clear from the folks who with a lot of experience in industry for address some of the root causes in some of these major events. For onshore facilities, the American Petroleum Institute in 1990 came out with Recommended Practice 750, and an industry initiative, but to help balance, to make sure that everybody played on the same playing field. Some companies that didn't follow safety regulations didn't have a competitive advantage compared to others. Regulations were promulgated in 1892. Process safety management came out. In 1996, risk management programs promulgated by the EPA. All things meant to balance the application of these safety management systems for onshore facilities. Offshore facilities, also in the wake of the Bhopal tragedies and also the Piper Alpha accident, in 1991, the SEMS concept was proposed, really by MMS, in collaboration with industry, and the concept was that there was an objective to be achieved. In terms of implementing safety management systems, the challenge was put forth to industry. The American Petroleum Institute put together recommended practice in recommended practice 75 in 1993 to address the effective implementation of safety management systems. This was monitored over the years, or the concept was that it would be monitored by the agencies over the years. So those insights were put together in an updates put forth in terms of recommended practice 75 over the years. And in 2004, that's our latest version, revision 3. And these were, again, ideas on how to effectively implement safety management systems for offshore facilities. In 2006, the Safety Environment Management System concept was promulgated and put forth in the Federal Register, which was a simplified version of SEMP. And in 2009, it was put out as a proposed rule for review and comment by industry and agencies alike. Solution of the kind of applications for offshore facilities as well as onshore was to provide mechanisms for effectively implementing safety management systems in a way that could be done practically for both offshore and onshore facilities. Bottom arrow is an analogous approach. Complicated, we'll talk about that in a few minutes, for applying safety cases over in the Kingdom. Again, in the wake of the Piper Alpha accident in 1992, the original safety case requirements were put forth. Those were implemented over the years, and an updated version was put out in 2005. And this also has put out various guidebooks, and specific for mobile offshore drilling units, a HSE case, Health Safety Environmental case, a book was put out in 2009. So again, the evolution of these things, it was encapsulate good concepts for managing the safety at facilities that could potentially be very hazardous. So what I'd like to do with that is talk a little bit more about offshore, about the regulatory environment. Then I want to start getting into some of what these techniques are and also practical applications. But I'm not going to read through it, but it kind of illustrates the fact that in the United States, there's a bit of complexity in terms of the jurisdiction of our agencies. Onshore marine facilities that are connected to offshore facilities are often regulated by the same agencies and in the same way as in shallow waters. The divide for most states is up to 3 miles from shore. Over in Texas, it's 9 miles. And basically, at that point, after that, you get into the outer continental shelf. Different agencies regulate the outer continental shelf, or would regulate safety management systems for the outer continental shelf, waters, the shallow waters, and also for onshore facilities. A quick summary that will probably turn out to be more useful in the months to come as many regulations get updated and reformulated as a result of some recent occurrences in the Gulf of Mexico. Texas, again, up to 9 nautical miles. You've got state waters that are controlled by state agencies. Currently, there are a lot of design and operating guidelines and requirements, but no specific safety management systems. That also applies to Louisiana and Alaska. Those state waters go out to 3 nautical miles. California always a little bit different. California state waters go out to 3 miles, but you do have an agency, the State Lands Commission, that regulates and applies safety management systems concepts as a basis for inspections, audits, and enforcement. You also got in California certified unified program agencies that for some of these facilities that are onshore, they also regulate some of the highly hazardous materials. It's regulated. We'll look at that in a couple minutes. In terms of the Outer Continental Shelf and also federal agencies, Minerals Management Service currently regulates the Outer Continental Shelf. The SEMS guidelines have been out there, and also the SEMS proposed regulations. Those are out there, again, applying or looking to apply safety management systems to facilities on the Outer Continental Shelf. The Environmental Protection Agency's Risk Management Program, EPA does have jurisdiction for the OCS, staters, and also onshore, and there's a specific risk management program that applies safety management systems. However, most offshore drilling and production facilities are exempt for reasons I'll explain in a few minutes. There is a general duty clause that can be invoked to implement these safety management systems if the EPA deems it necessary. A similar situation exists for OSHA. OSHA Safety Management is a program that is regulated by them. Most offshore drilling and production facilities are exempt. However, the general duty clause, should they choose to implement that and require that for state waters and also onshore facilities. Coast Guard also has jurisdiction for state waters and marine facilities that are onshore, but it's primarily looking at equipment functionality, and there's no explicit safety management system that applied for the Coast Guard. So where do some of these exemptions come from? Both OSHA process safety management and risk management programs, as I mentioned, they do have jurisdiction over offshore facilities, but these facilities are typically exempt due to the fact that they're naturally occurring hydrocarbons, and they fall below certain NFPA and flashpoint ratings. Again, there are exemptions for storage in atmospheric tanks, and also if there's a certain limit below which there's no direct requirement to apply these safety management systems. So, back overview of the regulatory environment and some of the jurisdictional boundaries and what's out there with respect to current regulations. What now is shift focus and get back to our main theme. What are the safety management system programs out there? How can they be applied effectively so that you're familiar with that? And should these things come up, what are their benefits and drawbacks? So start with the most commonly applied technique and the ones that's used very, very frequently for offshore facilities, and that's the environmental management programs. Basically, the 12 elements on the right are out of the American Petroleum Institute Recommended Practice 75. Circles on the left illustrate some of these key elements. Environmental information, hazard analysis. Some of these circles are red. The reason being is starting in 2006, the Safety Environmental Management System concept, or SEMS concept, was proposed that basically took the SEMS elements and said, all right, to help simplify implementation, what do we consider the most important elements of SEMS to ensure that we can at least get a focused application out there for all offshore facilities. The ones in red were the ones considered the most important, and those are the ones subsumed into the SEMS approach. Those that are considered most important, the ones in red, hazard analysis, management of change, operating procedures, and mechanical integrity. The others in green, safe practices, training, pre-startup reviews, emergency response and control, incident investigation, auditing, and also records, keeping good records and documentation. They're all other elements of SEMS. What we're going to do is, in a few minutes, talk to you about some of the other programs out there and talk to you specifically about some of these elements. I'll be turning it back to Esther, and I'll also be introducing Carlos Cheek, who will go over these elements and provide you with a little bit of background on those. Again, all these are encompassed by Recommended Practice 75. The of it is in the top bullet. And this is industry's response to help implement the SEMS concept that was proposed in 1991. Before, we're in the third edition, and Recommended Practice also includes recommendations for effective implementation. Other tools are out And these are also referenced by Recommended Practice 75. API, American Petroleum Institute Recommended Practice 14C and 14A are two that are one of the most commonly applied that pertain to process safety and also the implementation of safety management systems. 14C is titled at the top, Analysis, Design, Installation, and Testing of Basic Surface Safety Systems for Offshore Production Platforms. These are to provide design information, providing component configurations, flow diagrams, P&IDs, piping and instrumentation diagrams, alarm features, and also providing safety analysis checklists. It's going to provide design background and a good design platform for having a strong safety system, and also to provide safety analysis methods, and also the development of safe charts to help implement these design concepts adequately. It is also very important and also referenced by Recommended Practice 75. It's the hazard analysis for offshore production facilities. It focuses on two of the key SEMP elements, safe environmental information and also hazard analysis. And the idea is how do you implement those effectively, find good design practices. And again, the applicability was expanded a little bit to the offshore production facilities and also production processing systems of mobile offshore units. Other key safety management system tool technique, and this is something that has been widely applied outside the United States, has been specifically required in the United Kingdom and the waters of the United Kingdom by regulation in 1993 and updated in 2005, and that's safety cases. The safety cases are specific for offshore installations, and the idea is that you've got a documented body of evidence that provides a valid argument or basis for saying that the system is adequately safe for an application for a given environment. You're looking at the environment, the consequences of what that hazardous materials facility can do, and looking at how strong do the safety systems need to be, and then implementing a prevention program to make sure that the facility operates safely. Key requirements in the original 1992 implementation was a fire risk analysis, looking at the risk of ingress of smoke or gas into the accommodation, looking at emergency systems, evacuation, escape, and rescue analysis. These 4 points are directly correlated to a lot of the issues that came out during the Piper Alpha. Over the years, the safety cases were implemented. The 2005 update included a design notification, a review of these safety cases at least every 5 years, although relieving the resubmittal requirements and basically making sure that the operators are fulfilling their legal requirements to operate their facilities safely. Some of you recognize the diagram at the top as a bow tie diagram. For those of you who don't recognize it, bow tie, quantitative risk assessment, these are all relatively synonymous terms designed to quantify and look at threats or the potential hazard initiators, what keep those hazard initiators from causing a release or other undesired event. Should they occur, what things can ameliorate the consequences, and then go into the consequences themselves. So the idea is that those little circles on the screen are barriers between the initiating event threat, the consequences, and the different consequence categories that can occur. Various tools are put into place, and we'll talk about the tools in just a second. The contents of safety cases include a facility description, what the management system is. That's basically the theme what we're talking about today. Having a formal safety assessment, safety critical elements, performance standards, as well as reasonably practical demonstration that you've reduced the risk to as low as reasonably practical, and justifies a fitness to operate. And things revolve, for those of you who have applied quantitative risk analysis, all these apply in the field of quantitative risk analysis and also safety management systems. These ellipses represent all the different tools and techniques that you might apply to various safety cases. Includes things like event trees, fault tree analysis, hazard and operability studies, what-if studies, hazard analysis, quantitative risk assessment, benefit cost analysis, all these tools that could be useful for describing the risk, for quantifying the risk, and for loss prevention afterwards are things that are evoked as necessary during your safety case. So the safety case states requirements, states objectives, and it encourages the operator of the facility to develop a plan to make sure risk is minimized and kept under control. These programs, if you look at them, and I've tried to lay this out in terms of the most common programs and the safety management systems identified out there. If you look at safety cases, it basically encompasses quantitative risk assessment as appropriate, quantitative risk assessment tools, safety management system approaches, things like the safety environmental information, operating procedures, and training, and all those are encompassed by a safety case. That is SEMS. This is on loss prevention and various management system techniques for preventing major undesired events and a facility that operates and handles highly hazardous materials. SEMS, as we mentioned before, was a concerted effort by industry and agencies to identify the most important elements of SEMS and make sure those got implemented. So this diagram that you're looking at illustrates the breadth of these various programs. SEMS is encompassed by SEMS. SEMS is basically encompassed by safety case. And a little bit later in the presentation, talk a little bit more about regulations. Consistent with the main theme of what we've been discussing, we want to also keep identifying some key programs that are out there, some that are working, being implemented well. And I'd like Esther to talk about a state program where you see safety management systems being implemented that seems to be very effective, some industry programs that are out there, and some other techniques that can be commonly applied. We're going to go right back to SEMP because it's a key part of PI recommended practice 75, and it's also a very commonly applied tool, provides a lot of useful guidance and information for managing the safety at these facilities. Esther?
Okay, so we're just going to do a quick review. Obviously, there's plenty of literature out there to, delve into some of these key topics I'm going to bring up just briefly. The whole idea here is that there's a vast amount of literature, regulatory professionals, industry professionals, whether it be actual companies and corporations themselves that own these facilities and operate and maintain them, or consultants that are out there. There is a vast pool of resources that are well-versed in safety management, process safety management, whatever you want to call it, and are implementing it out there. So I'm not condoning one or other program. I'm just saying out examples that are professionals out there that know how to know the regulations and know how to implement it and audit. We're just going to bring up real quick the California State Lands Commission. Basically what they do is they just draw on literature that's out there on safety management tools, process safety management. They definitely look at 14C, 14J, some California process safety management, and they just try to draw from the best practices and recommended practices in industry. And to implement a safety audit program in the state of California, it seemed a little scary at first or overwhelming when you first look at what they're actually auditing these facilities on. Equipment functionality, integrity, technical design. They want to see that these things are up to the latest codes and standards, designed to the latest codes and standards, tested, inspected to the latest codes and standards. They do electrical condition maintenance and design. An in-depth audit, and then a unique part of regulatory practices is the human factors and safety management aspect, which includes the SAMS program. And one interesting thing about their program is they've done 15 of 20 installations, and it resulted in, it started in about 1999 and had about $5 million. Their recommendations for industry of aggregate have resulted in about $5 million for everybody since 1999. So it's not as getting and as daunting of a task when you think about new regulation being passed as you might think. An example that Ester gave a presentation at a Prevention First 2006 symposium. This is just one slide, kind of encapsulated their program. This is a company, Offshore company, so a rigorous internal program that they adopted. They call it the System of Operating Excellence. And it's just to show you that there's a lot of people in the industry that are voluntarily doing these programs. It's safety management systems, process safety management. As you can see from the diagram, they've pretty much encompassed a lot of the key elements that are outlined in SEMS. This is just a term that's thrown around a lot. It's called behavioral-based safety programs. At first glance, this might seem a little daunting. Really what it is it's just looking at the safety culture of an organization. So when you're looking at developing a program, a safety management program, it's not just about writing procedures, forms and procedures and policies out there. It's really about the whole top to bottom safety culture in an organization. You really have to look at employee behaviors to understand why are they doing these things, why are they taking some shortcuts, or why have we deviated from the design intent. People do not inherently want to put themselves, workers, the environment at risk. They have reasons for doing it. So just BBS approaches, basically emphasizes the influence. Current practices do influence, do recognize and emphasize the influence that managers, systems, and businesses have on at-risk behavior and conditions. You really have to have upper-level management. And you implement these programs, you have to do it in a non-threatening, non-blaming, not pointing the finger environment. You've got to just objectively get everybody together and create a forum where people can give honest feedback, and you can really down to the bottom of the behaviors in your organization that are high risk or behaviors, and just let's move forward. Let's not look in the back, the past. Let's not point fingers and blame. Let's just move forward. You contribute these kind of behaviors to one person, wrong, bad, good. It's a cultural thing in an organization. And basically, when you do behavior-based safety program auditing, you look at, it's just intended to flush out process safety indicators. Those are indicators that were at the very beginning of the presentation that can be subtle. They become normalized because it's something that people are doing constantly as part of their day-to-day activities, to the point where they don't even recognize the fact that it's a hazard or it's an at-risk behavior. So when you take this behavioral-based approach to implementing SEMS, the whole is to try to flesh out these process safety indicators. These are just real quick examples. This is where you just kind of have this approach and mindset in your head when you're approaching the implementation of SEMS, because these are examples of common findings that you see out there in industry. It doesn't matter whether it's offshore, onshore. Our company, we work with micro and small businesses, and we work with obviously international corporations. It really doesn't matter the size of the company. We pretty much find the same integrity not kept up. Usually, that often is a sign of you don't have adequate maintenance staff or parts to close the work. It's not really a matter of people not wanting to; they just don't have the ability to. You have informal pressures. The second one, in Chemical Safety Board case studies, that just comes up over and over again. Whenever you have a lot of informal pressures for performance-oriented culture, in which employees praise for saving time and taking shortcuts, minimum costs. The times when the major case studies there, that was one of the factors, usually factors involved. Because again, process safety is multidisciplinary. It involves a whole organization, top to bottom. It's really not a handful of people. Another thing too, when you're auditing, you need to resolve the deficiency. The deficiency isn't just that the management change form wasn't filled out properly or followed up on, or that the maintenance forms and work orders weren't closed. We got to get down to why? Why is the procedure, form, or policy not being filled out? What can we do as an organization to make this easier to fold into our day-to-day operations? And adopt it as a cultural thing, not just for some form or document or policy. People have to stop what they're doing, stop operations, and let's fill out these forms. And it's got to be natural, day-to-day ops. And so, like, now, the P&IDs reflect the system piping instrumentation diagrams from like 15 years ago. Because there's in-house CAD people or they're overloaded, nobody redline and trace the system to update the drawings. Just very simple things. It sometimes comes down to not having the resources to get it done. Same thing for operating procedures. Okay, so that's just a quick overview of let's not reinvent the wheel. There's a lot of things out there that people are doing in other industries, and there's so much overlap that we don't want to reinvent the wheel. I'm going to introduce you to my colleague, Carlos Cheek. He's another project engineer at Risk Management Professionals. He received his bachelor's in mechanical engineering and his master's in mechanical engineering from the Rochester Institute of Technology. He trains in the regulatory arena while working at the U.S. Food and Drug Administration. He's pursued a career in process safety management to gain exposure to a huge spectrum of industries and processes. Carlos has been instrumental in finding simple implementation and management solutions for small and medium-sized businesses regulated under state and federal regulations such as EPA, RMP, OSHA, SEMS. Prior to his outreach to local oil and gas facilities, Carlos has been working closely with regulators to ensure that the facilities stay ahead of the ever-changing regulations. And during his tenure with Risk Management Professionals, Carlos has used his talents to discover practical solutions for safety management systems applications that he has presented at statewide regulatory forums. So I'm going to introduce you to Carlos.
How about now? All right. Thanks, Ester. She said I'm going to be going over some of the SEMP elements, and I'm going to quickly discussing ways that a facility can make these useful. These are a useful tool that a facility can use in the everyday operations. So first, the safety and environmental information. This is simply a compilation of all the information of your facility, of your process. This is a thing starting with the block flow diagram and the P&IDs to safe upper and lower limits, operating temperatures and pressures. This is simply all the information on your equipment, the specifications, together in one place. So then you make decisions on your process as far as safety, environmental, things like that. Some quick examples. This is a good example of a process flow diagram. It's a simplified P&ID, so you kind of see everything all in one place and get an overall picture of what's going on with your process. And so P&ID. Up-to-date P&IDs are very, very important, as Esther discussed earlier. When you make decisions on your process, when you're working on it, you don't want to be working on a facility that you had 10 or 15 years ago. You want to be working on the facility that you have now. So when you make those changes, when you make those decisions, they're informed and they're correct. You make a good use of your time. When you start to sit down and you look at P&IDs and you look at these things, you use time, and you want to be able to use that time efficiently. And good, up-to-date P&IDs are very important in that decision-making process. And then our MSDS sheet, your safety environmental information also should have all the information on the chemicals in your process. And the MSDS sheet is a good place to start with that. So good, up-to-date MSDS sheets on all the chemicals in your process are important as well. This element is the hazard analysis. Analysis basically tries to fail your system. It looks at all the potential points of weakness in your system and identifies the risk in that process. Then lists the worst case consequence. Risk. Okay, this could potentially happen. Develop it with the team to say, what is the worst case consequence if to occur? And once you define that worst case consequence, you then add in your safeguards.
So you have all these safeguards protecting you from this risk, or potentially maybe you don't have as many safeguards. And once you have your worst case consequence, you have safeguards, now you have an objective method to determine, is this an okay situation? Is this risk acceptable? And then you can then make that decision using all the information. And so where it's important, where you have a good safety environmental information, you can make these decisions. You can follow the things that you have in your process and apply to your situation that you have in your hazard analysis. Symbols that you'll see in the hazard analysis, it ranges from less effort to increased effort. And you start on the left with a simple checklist or a what-if analysis, and then move into things like the 14C recommendation and the hazard and operability study is increased effort, but you get increased insight as well. And then some of the more overall right, you get things like the LOPA and fault analysis, which you qualification of risk. And then this is much more increased effort, but increased insight from that effort that you put into it. So things you get in, what you put out. Management of change is something I work a lot with, and some people see it as a hindrance in production. And back in the day when I worked at General Motors, I really didn't like when production was halted or stopped for something that didn't really seem important. I work closely with facilities to make sure that the management change can be a useful tool and doesn't hinder production, but can make it more efficient. Basically what the management of change does is it gets a team together and says, hey, first, what are we changing? Let's document what we're changing, document why we're changing it, and seeing what we're changing, why we're changing it. Let's make a list of all the things that are changing because of that. Do we need to update our P&IDs? Do we update our operating procedures? Do we need to update our safety environmental information? So a list of the things that we're changing at some larger facilities, and then assign people to make changes. Maintenance manager, you need to change the P&IDs. Operations manager, you need to change the operating procedures. So make assignments, like some dates. So let's get back together when this needs to be put online. Then you do a pre-startup safety review. Changes get made. Are P&IDs ready? Are operating procedures ready? Have people been changed and informed of the change? Check, yes, yes, yes. All right, now sign off, and you start the process up, and you're ready to go. So all done is we made a list of the things that need to get done and send them to them, and then we just documented that. That's all management change does, is document the things that all need to get done. So I think the management change, when done correctly at a facility, can really make it a very more efficient change and not be a hindrance to production. Procedures, you need to have documented operating procedures, paper in hand, for initial startup, no operations, temporary operations, emergency shutdown, and normal shutdown. These to be documented in hand. They can be, oh, no, so-and-so always runs the plant, so he's the one who knows how to do it. I always use the example, well, if so were to leave, would anyone else know how to run that part of the process? And be like, well, no. It need to be in paper, in hand, so that everyone can be picked and trained on that operating procedure. Procedures need to contain things like the consequence of deviation. So when you see this gauge go this high, you need to leave this valve. Things like that need to be on operating procedures, so that way someone who can pick these operating procedures, be on them, and then be able to run that process safely. Quite as efficiently as someone who's been run the process for 10, 15 years, obviously, but run the operation safely. And everything that needs to be done is on those operating procedures. Have precautions necessary to prevent exposure, controls to avoid contact, And the operating procedures need to be reviewed periodically. Pick up those operating procedures and say, hey, is this still what we do? Even if nothing has changed, maybe the process has been made more efficient. You just need to pick those up and look at those again and sign off on them and say, yeah, these are still the operating procedures that we use, and they work well. Practices is the next element in SEMP. Basically, you start with your contractors. Contractor selection is an important part of SEMP. API Recommended Practice 76 contains guidance for the contractor selection. And they have operating procedures, written procedures for things like how do you conduct a lockout tagout procedure? How do you do hot work permit? Who do you need to take that hot work permit to sign off on that it's done, that you have a watch time, things like that. Those need to be documented in the hot work section. It can't just be a permit, oh, we take it this and this and this. It needs to be documented who takes it to where and who signs off. Confined entry and crane operations deal there. And to have control of hazardous materials, which is simply how you control those hazardous materials, where they're stored, how they're stored, what they're stored in, things like that need to be documented. For platforms, there needs to be an initial training, which AI has a list of training that they recommend, and that's on the slide, which I'll walk through briefly. So they have initial training when someone's brought on or when they're introduced to a new process, and then you need to have periodic training to check up to make sure that those people are still retaining the knowledge that they need to perform their tasks. Whenever a change is made, whenever an MOC is initiated, training needs to be conducted on the appropriate personnel to make sure they know how to perform that operation, know the change has been made, oh, we're not using this valve, we're using this level, this is the pressure, it's changed now, things like that. Contractors, whenever you bring a contractor on site, they need to be trained in the operation, general safety of the offshore facility, evaluation procedures, things like that. API laid out, it basically starts with recommended practice T1, with the orientation for a first-time person's being brought onto a platform for the first time. And they have a range of trainings all the way up to eventually when they're operating process involving hydrogen sulfide, which we all know is pretty serious stuff. So they have a range of trainings that can be done for personnel based on their needs. Mechanical integrity is something that facilities struggle with and whatnot, but it's basically just, are you keeping up your facility? And each facility is definitely doing the mechanical integrity because the facility is working, and everyone knows that they have to do this and they have to do that, but it's documenting that they're actually doing it, and then more importantly, it's putting a plan together, a schedule, a preventive maintenance schedule. So you know that in March you have to fix this pump and whatnot, but you have to document that schedule. So you can so basically you should be able to say, hey, what maintenance are you doing, next year at, in March? And you should have that plan, pull it out and say, this is our schedule that we have, this is our preventative maintenance plan, and that prevents you from having a fix-it-failure type system, type operation. We have a range of tools, again, that you can use for mechanical integrity. Everything from, the memory of the maintenance managers, post-it notes, things like that written down. You have a maintenance contractor, they'll take care of stuff. Again, they might not, you need to have the documentation of the preventative maintenance plan. You need that as a facility, the plan of what the maintenance contractor is going to do. So you can do that your contractor is indeed doing what is necessary. You need to be responsible for your contractor. Some of the computer maintenance management systems, SEMS, basically as a computer program, some that work a little better than others. So some are more intuitive than ones that require significant training. Also, usually web-based programs are more easily accessible as opposed to self-standing program. So we said, there's a range of CMMS programs that you can find. Some are a little bit easier to use, and then obviously you'd want to use an easier to use program. the mechanical integrity program is a work in progress. It's always going to be developing your mechanical integrity program. Once you get it in place, you get the documentation, the plan. This is what we're going to do monthly. This is what we're going to do every 6 months. This is what we're going to do every year. Now you go through that. You start, looking at your system, things working, and things change. You need to, okay, actually we need to bump this up to every 3 months because of such and such process, or we don't need to do this so often because it's actually running better or for whatever reason. Then you go and implement those changes, and it's a cycle, and then you see how that works and whatnot. The baseline for this is obviously the manufacturer's recommendations of what is the bare minimum of what needs to be done to a specific part, pump, relief valve, things like that. But after that, there is a work in progress of what works for your facility. Review is something that's implemented every time there's a management change, or every time that a new process is brought online. So it's basically just a checklist of all the things that need to get done for that piece of equipment to be brought online. Have people been trained, P&IDs, things like that we've been talking about before. It's just a double check just to make sure all of those are done before that piece of equipment is brought online. Everything is yes, yes, yes. You have someone sign off on it, and you go ahead and bring that piece of equipment online. Response control. This is something that a facility needs to have in place to make sure in the event of emergency, there's the proper procedures to be that are in place to avoid emergency or when it happens. Basically, you start with the ICS program, and then you also need to address events such as full of hazardous substances, collisions, fire, and or blowouts. And of course, the important emergency response is training to make sure the facility is properly trained and they're aware and up-to-date training and lots of drills. So that's something that does happen. It's quick and everyone's responsive and knows what's going on. I'm going to talk briefly about ICS training, incident command system. Basic way to make sure that the proper the chain of command is in place, that every job that needs to get done has a specifically assigned person to that job and very defined roles and exactly what they need to do. So, you are in charge of this section, and this is exactly what you do, and immediately once you're in that job, all responsibilities. Some things about ICS is that's the terminology. Once something happens, everyone's on the same page, everyone is able to speak the same language, everyone knows these responsibilities of each other, and they're very quickly able to start taking action instead of having to worry about logistics and things like that. Another important part about ICS is that it's scalable from the very smallest of incidents to obviously the very large. The same command system works. Of incidents is one of the next sections of SEMS. All incidents must be investigated and have a written report, including the near misses that Ester was talking about earlier. Initiate the incident investigation as quickly as possible, and also need to let everyone know about the recent conclusions of the incident investigation. The appropriate personnel need to be informed, hey, we had this happen, this is what came about it, these are the changes that have been made, things of that nature. Everyone needs to be informed of what's going on with the incident investigation. Investigations should address the following, should address things like the nature of the incident, factors that contributed, and then changes that have been identified because of the incident investigation. All should be included in the report. You need audits of your SEMP program. It's put in place. You need to have the audit after it's put in place, and then after that, at least every 4 years. Facilities we've seen, a lot of them do it every 3. Document the findings of the audit in a report, and then also address deficiencies in your SEMP program. Make changes. Hey, we need to, type up our safety environmental information, things like that. And then needs to address technical compliance what's actually documented, the technical compliance, as well as the actual effectiveness of the program. Hey, is our mechanical integrity program working? Let's talk to the maintenance manager. Let's get him here and see what's going on. Is it too strict? Do we need to, make the paperwork maybe a little lighter, or maybe a little bit more, checks and balances on that? Let's need to talk to the people, have interviews, and make sure that things are actually working. And documentation is really a double check to make sure that you're maintaining all the records of the elements that we've talked about previously in a spot that is organized and that it's all there basically for your audit is the important part of records and documentation. That's everything organized and ready to be audited, also obviously accessible. So use it on a day-to-day basis. So we'll spiel on SEMP, and hopefully you can implement SEMP and use it on a day-to-day basis, and it doesn't need to be to production, but actually can make it more effective. I'm going to turn it over to Steve right now, and he's going to talk about regulatory dynamics.
Thank you. Okay, what I'd like to do is kind of round up our discussions this morning. What we've been discussing, basically what we've been doing is we've been looking at the safety management system techniques that are out there. There are a bunch of things that are proven to be useful for both onshore and offshore applications. We also looked at the key elements of the SEMP program. It represents the mainstream, if you may, of offshore applications of safety management systems, and the concepts that are out there, the key elements. Many of you who are involved in process safety management and management programs recognize the fact that there's a significant overlap. The SEMP program that represents the mainstream of offshore applications really has a lot of elements that are directly analogous to the mainstream safety management system applications for onshore facilities. So this is that the tools and techniques are out there. And what I'd like to do is take a look at the current regulatory environment and talk about how those tools can come into play. So I'd like to start with a little bit of background. As we discussed earlier, just like the formulation of the Center for Chemical Process Safety, Director Bhopal led the development of tools and techniques that were eventually promulgated as PSM and RMP. For the offshore industry, you got a lot of elements that were proposed in the 1991 timeframe and evolved into SEMP in 1993 and further evolved in 2004. As a more streamlined mechanism for implementation, SEMP came about in 2006 and became a proposed rule in 2009. There's a lot changing right now. Just recently, and I've listed a lot of key dates, there's a restructuring order for the Minerals Management Service, a brief to the President from the Department of Interior on May 27th. There's a moratorium going on for deep water drilling facilities, but also lots happening. The June 8th directive from the Department of Interior for shallow water drilling operators is meant to address some of the direct some of the direct causes and the direct issues associated with the Deepwater Horizon accident, things like maintenance, monitoring, and design of blowout preventers, and also various operating procedure issues. Near-term requirement to address these things, again, for shallow water operators. All these things are going to get packaged up, discussed over the upcoming weeks and months, and rather looking at September for a possible rulemaking expansion of June 8th directive. Taking some of these ideas, developing it further, and making informal rulemaking from that. Those are meant to address direct issues and contemporary issues associated with the Deepwater Horizon accident. With respect to safety management systems, tools and techniques are out there, the guidelines are out there, and it's really a matter of packaging that and you should be looking for rulemaking toward the 2010 or early 2011. Pretty much as was identified in the May 27th brief, packaging these safety management system concepts, making sure that they're uniformly applied for offshore facilities. And in early 2011, the Department of Interior is actually going to take the portion of MMS associated with regulation and enforcement and create the Bureau of Safety and Environmental Enforcement. These are things that are happening right now. It's very, very dynamic environment, but it is very clear the safety management systems concepts are important and will be a key part of this. What to do is kind of share with you a little bit about some of the mainstream concepts out there. What's out is obviously going to have to address things like operating procedures, mechanical integrity, assessing hazards, and mechanisms for control. As we discussed earlier, safety environmental management systems is one of the more straightforward approaches. SEMP maybe presents the mainstream, has 12 key elements that most of them which correlate directly to other safety management system programs. Safety cases encompasses the safety management systems and also does a lot of quantitative risk assessment. I personally have been involved with formulating some of the early programs for safety management systems, done a lot of hazard and operability studies and other hazard analyses, and had the privilege of being involved in one of the early plant safety shutdown design studies that done. That was back in the days when we were comparing analog safety devices to digital devices and some of the more functional logic controllers that we've got now. These represent a wide range of safety analysis and concepts. What I would look for is not the invention of something really new, but I think what we're moving towards is the implementation of techniques out there. So understanding those techniques and see how they can fit into an overall safety program is very important. And that's really our objective today, is to provide that kind of information. Again, I would expect in terms of evolution in the current environment is to get settled on uniform application of safety management system programs that somewhat within the range of the well-applied programs that are on this slide. And the range is from fairly simple to very complex. What I'd like to do is really emphasize that we're not reinventing the wheel here. These programs are out there, these techniques are out there. One of the really items of good news is that since they're out there, companies that have offshore facilities and also have onshore facilities really already have a lot of the resources necessary for invoking these commonly applied safety management systems elements. They've got the resources within a company to do this effectively, to do fairly quickly actually, to improve the overall level of safety at offshore facilities. Again, the resources are there, the technology is there. It's not that difficult for industry to actually use its own resources. You don't have to import it. You don't have to develop anything. Most companies have these resources in-house to make for an effective program. For convenience, is one of those slides we got here. I provide a correlation matrix that compares the SEMP elements with the analogous elements of process safety management and risk management programs. And again, in many cases, the implementation is more similar or nearly the same than it is different. So stuff going. There are a lot of changes right now, and it's a very dynamic environment. I want to let you know we're going to stay on top of it. We're going to continue our webinar series to try to provide people with of technologies that are out there, how to effectively implement these techniques. And next webinar on offshore platform safety management systems with a bit more depth on some of the techniques, and we'll also be providing an update on the dynamic regulatory environment. That's currently scheduled for June 22nd. So I hope that everybody can tune in. And we're on top of it. Hopefully you guys June? Okay, good. I'm glad somebody's listening. And it is July 22nd. June 22nd. June 22nd would be a little too soon and probably not have a lot of new information. Our July 22nd webinar, we are hoping to expand on this, give everybody an update, and provide everybody with a lot of information. Anybody who isn't getting our newsletters, getting our training schedule for these free webinars, please give our office a call, and we'll make sure we get you on the list. Put the phone number up on the screen again at the very end. There's this is a lot of the key references that we've been making when we talked about regulatory history, the evolution of some of these requirements, and we wanted to consolidate the list and make a nice little list of references for you in the back. I guess what I'd like to do right now, primarily, is thank everybody who attended and who've been paying attention all this time. I hope you got something of it. I'd also like to thank our speakers, Ester Brawley and Carlos Cheek, and also our producer, Nicola Tromba, for helping pull all this stuff together. At this point, we're going to go ahead, and as I mentioned earlier, the mechanics of a webinar is we had to have everybody muted so that everybody wouldn't get drowned out, but we can open it up for verbal session, direct verbal comments to the comments or questions to the speakers, and using your chat box on the webinar screen, you can put questions anonymously or directly, and we'll be glad to entertain those. Okay. From the ads. Yeah, that's a good point too. Everybody's got our email address. The phone number on the screen too is a good way to find us, as well as our website address. If you do have follow-up questions, or you're not getting our newsletters. Also, for the audience here, this is being broadcast from California, by the way. For the audience here, did you guys have any questions or points that you'd like to raise? Lots going on right now. Hope everybody's staying tuned to the news, and I really hope for the best in terms of getting things under control in the Gulf of Mexico right now with all the people who are involved in emergency response. Anything? All right, in that case, we're going to go ahead and sign off now. Everybody does know how to contact us if you do have any other questions. Thank you for participating and for your attention.